To address this issue, we will generate a risk score for the generated postmortem report, and we will involve a human for approval before it's sent out. Amongst the retrieval failures, a common failure is that agent may fail to retrieve relevant historical knowledge, or it may miss critical evidence during its investigation. We have already addressed this issue by incorporating long-term memory, evidence coverage checks, and an evidence gathering loop, which will allow the agent to collect additional information before it reaches the conclusion. Tool errors are another type of errors, and they can impact the quality of investigation. If tools return incomplete or inaccurate information, then agent's analysis will suffer. We cannot completely eliminate the tool failures as they depend upon external systems, but we can reduce the risk by using standardized schema for extracting evidence from tools' output, and we can implement traceability. Amongst the workflow errors, one common failure mode is agent may stop investigating too early, and the resulting analysis may be shallow or incomplete. Our current architecture already mitigates this risk as we have the need more evidence decision point and the evidence gathering loop. In enterprise environments, it is important to implement explainability of agents' decision, as it is important for auditing, debugging, and building trust. For this, we will capture traces, decision logs, and evidence records that will provide visibility into agents' behavior. And for any high business impact incidents, the risk scoring and human approval before finalizing high risk outputs will minimize the risk. Human factors are equally important when we are designing the reliability controls. Even when a human reviewer is involved, they may not have enough information to make an informed decision. To improve the review quality, we will ensure that human reviewer receives not only the draft postmortem, but also supporting evidence, critique results, and validation information. And finally, to improve agents' adoption, which depends upon the trust, we will implement evidence-backed reasoning, tool traceability, and transparency throughout the workflow. So these are some of the reliability controls that we will add to our agents architecture. This is the architecture that we started with. And as a first step, we will introduce input validation, which will ensure that the input request contains information which is required for analysis. This will prevent any unreliable postmortem due to malformed or incomplete input requests. After the agent generates a postmortem draft, we have introduced a critique step where a second large language model will evaluate the draft for any weaknesses, inconsistencies, or unsupported claims. This will serve as additional quality control mechanism. And then we will introduce a step to calculate a risk score for the postmortem draft. And if the risk is high, we will route the report to a human reviewer for approval. To ensure that valuable lessons that agent learns over time are not wasted, we will add a step to save them in long-term memory. So we see that as a result of reliability analysis, what began as a simple agent has now evolved into a more robust and trustworthy system. Now that we have our target workflow, the next step is to define important data contracts that will move information between different components of the agent. Agents can pass natural language prompts between different nodes, but they become more reliable when we create structured data schemas for passing information. These schemas act as contracts between the workflow nodes, memory, tools, and human reviewers, ensuring that every component operates on consistent and validated information. The first schema that we have defined is the incident request. This is the entry point in the workflow, and in our lab, the request is intentionally simple. It contains the incident identifier and a request message for generating the postmortem. The goal is to keep the external interface lightweight while allowing the agent to gather any additional information it needs during the execution. The second schema is of evidence record, which represents the facts that are collected by the agent. Every piece of evidence which is retrieved from memory or MCP tools is normalized into a common structure represented by this schema. Schema captures source of information, the claim that the information supports, confidence score for its relevance, etc. Standardization of evidence allows the agent to reason over information from multiple systems consistently. As we discussed, these sources could be application logs, metrics, deployment logs, etc. The third important schema in our design is postmortem draft, which represents the output which is produced by the agent. Rather than generating a single block of text, the agent produces a structured postmortem which contains sections such as impact, summary, timeline, root cause hypothesis, supporting evidence, remediation actions, etc. This makes the output easier to validate, critique, review, and ultimately convert into a final postmortem document. Notice that workflow is transforming data from one schema to the other. We begin with the incident request, gather and organize evidence, and ultimately generate a postmortem draft. This structured approach makes workflow more reliable, testable, and maintainable than passing unstructured text between the nodes. And the last step in our planning exercise is to identify the tools that we will need for retrieving evidence. In a real world scenario, these tools may already exist in the enterprise systems, or you may have to create some. In our case, we need get incident ticket, which will retrieve incident metadata, including severity, impact, affected services, timelines, and any other contextual information. Search logs will allow the agent to retrieve relevant application log entries within the incident time window. Get metrics snapshot will provide operational metrics such as CPU usage, latency, error rates, resource utilization, etc. Retrieve prior postmortems will give agent access to any historical incidents and lessons learned to incorporate in the postmortem report. Lookup runbook will retrieve operational guidance and remediation procedures associated with the affected services. This will help the agent create expected recovery actions. Find open action items will provide visibility into any unresolved issues from previous incidents. In many organizations, recurring incidents are often linked to an action item that was never completed. Get deploy events will retrieve deployments and rollback activities that occurred during the incident window. Many outages are triggered by changes, so deployment history is a very critical piece of evidence. Now that we have defined workflow, data contracts, and tools, we have all the building blocks for implementing the agent. In the next episode, we will review the agent code by running it cell by cell in a Jupyter notebook. And in the episode after the next, we will learn how different agent components such as LangGraph agent code, memory, tools, etc. can be deployed in a production environment.